Welcome students. In this class we will be learning everything about hyperbolic functions. And foremost, it is imperative for everyone who are aspiring to gain a mastery on hyperbolic function to understand the very fact why do we need hyperbolic functions. Now when we talk about hyperbolic functions, we are talking about Sinh, Cosh, you can just say Sinh x, cosech, tan x, hyperbolic tan x, and then their reciprocals. Now it is imperative to understand that understanding these functions, hyperbolic functions in general, will allow you to understand complex math concepts. In other words, when I'm talking about complex math concepts, I'm talking about, say for example, you have a challenging question and there is a related differential equation that describes that particular problem. Now you have to solve this differential equation to get the function. Now using ordinary functions, it wouldn't be possible to solve this differential equations, and that is when we resort to using hyperbolic functions, because hyperbolic functions have the ability to break down complex challenges to solvable problems. So that is the reason, that is one of the reasons, or I can just say it's the first reason that you all have to gain a mastery, because solutions to differential equations are the foundation in higher math education. Now I've been insisting on math education. Now why do we need math education? Because all creativity can only be achieved using math in the real life. Now you can go around, walk around, take a walk, and you can see the buildings, the devices, the apparatus, everything as the core, and inside the core you got a math. Okay. Now next comes, whenever we are talking about application, we cannot miss calculus. Now calculus is widely applied in all areas. Now in calculus we would be encountering certain integrals and differentiations. You cannot address these challenges using trigonometry, or I can say trigonometric functions. It is imperative to understand that trigonometric functions can only handle circular situations, because all these trigonometric functions are circular in nature. And what I mean circular functions, say you start from here, you walk around, you will have to come back to the starting point. But not all challenges follow a circular path, and in situations where the function is not following a circular path, you will have an issue applying trigonometric functions to solve them, and that is where we resort to the use of hyperbolic functions. So that's the second important application that I've given you. Okay, now let us take physics. Now physics is a very important subject, and in physics, if you are interested in waves and wave propagation, especially in the context where linear approximations are not applicable. So that means when we talk about linear approximation, we are talking about the small angles that trigonometry use. Okay, so in cases where this becomes obsolete, we resort to hyperbolic functions, and using hyperbolic functions, it is easier to understand the special relativity, particularly when it comes to the study of relationship between velocity and momentum. Okay, now this is application number 3, and let me go to application 4. I hope you all have heard about a beautiful subject called complex analysis. It is a branch of mathematics that deals with complex numbers. When we talk about complex numbers, that means we would be encountering the roots which have in its enclosure a negative number. Say for example, negative root of negative 16. Now this is a complex quantity. In the real line or in the real number world, we are unable to solve this, and that's the reason complex numbers are into the picture. Now when we deal with complex numbers, we have to deal with complex functions also. Now specifically when we talk about complex functions, hyperbolic function play a very important role in helping us to map and transform. These are two important concepts. Let me go on to application number 5. Now when we talk about circular functions, we are talking about trigonometry. As I mentioned to you, we can easily handle situations where objects are traveling in a circular motion. Okay. Now it is imperative to understand, if you have, say, something like this, a hanging cable, right? You have a cable that is hanging, and the topography of the cable is not a parabola, right? But it is an hyperbolic cosine curve. So the question now comes, how are we going to actually study this? Now we need to study this, right? Because we need to understand the characteristics of this cable. Now this cable can be used in many areas, many applications can be connected to this cable. So unless or until we know the exact nature of the cable, I'm just broadly using the nature, it's not possible. As I mentioned to you, this cable is actually an hyperbolic cosine curve. And this is another powerful application of hyperbolic functions, where you are encountering a situation where you cannot apply circular functions. Welcome students. In today's class we will learn all the formulae related to hyperbolic functions. So the first and foremost formula that you need to know is what is called as Sinh. I hope you're able to see this. Now Sinh is equal to e raised to the power of x negative e raised to the power of negative x divided by 2. You can either call it as hyperbolic sine or Sinh. So number 2 is cosech. Cosech is e raised to the power of x positive e raised to the power of negative x divided by 2. Number 3 is hyperbolic tan, or you can say tan x with the h sound. Now hyperbolic tan x is nothing but Sinh divided by cosech, which is equal to e raised to the power of x negative e raised to the power of negative x divided by 2. You write this and you flip it, you get 2 over e raised to the power of x positive e raised to the power of negative x, which is equal to e raised to the power of x negative e raised to the power of negative x divided by e raised to the power of x positive e raised to the power of negative x, because the 2 they get cancelled. Now number 4 is hyperbolic cot. Cot x is nothing but cosech over Sinh, which is equal to e raised to the power of x positive e raised to the power of negative x divided by 2 divided by e raised to the power of x negative e raised to the power of x divided by 2, which is written as e raised to the power of x positive e raised to the power of negative x divided by e raised to the power of x negative e raised to the power of negative x. Now this is negative, this is positive, have that in mind. So that is for hyperbolic cot. Now next, number 5 is going to be secant x. Now secant x is nothing but 1 over cosech, and cosech is nothing but e raised to the power of x positive e raised to the power of negative x divided by 2. You flip it, you get 2 over e raised to the power of x, positive e raised to the power of negative x. Now number 6 is cosech, cosecant x. Cosecant x is equal to 1 over sin x. So that's going to be 1 over e raised to the power of x, negative e raised to the power of negative x divided by 2, which is equal to 2 over e raised to the power of x, negative e raised to the power of x, right? E raised to the power of x, negative e raised to the power of negative x. Okay. So number 7 is a very all important formula, that is cos squared x negative sin squared x is equal to 1. Number 8 is cos squared x is equal to 1 positive sin squared x. I will write number 9 here. Number 9 is sin squared x is equal to cos squared x negative 1. Number 10, I'll write this over here. Cosh 2x. Now cosh 2x is cos squared x positive sin squared x, and it has another representation, so I will just place the representation over here, 11. I can also write cos 2x as cos squared x positive. Now sin squared x is cos squared x negative 1, so this is going to be 2 times cos squared x negative 1. So this is cos 2x. Now cos 2x is also written in this fashion. So cos 2x is equal to, now cos squared x is 1 positive sin squared x. So 1 positive sin squared x positive sin squared x, which is equal to 1 positive 2 times sin squared x. We never know which we would be requiring, so that's the reason I'm giving you all of the formulas that would be required. Okay, so the next one is number 13. Okay, so let me just, okay, all right, number 13, this is for, okay, tan 2x. Okay, number 13, tan 2x is equal to 2 times tan x. Okay, let me derive the formula for tan 2x. So tan 2x is nothing but, let me write it like this, sin 2x over cos 2x. Okay, so that would mean I need to give you what is sin 2x, right? So let me take this as formula 14 and let me write formula 13. Sin 2x x is equal to 2 times sin x times cos x. So this is a very important formula for sin. Sin 2x is equal to 2 times sin x times cos x. So if I were to write the representation for sin x, this is going to be 2 times sin x times cos x divided by cos 2x. Now I wanted to get rid of this cos 2x. So what can I do? If I were to substitute, I need to choose the substitution correctly. Now in place of cos 2x, I'm going to use this formula. So that's going to be cos squared x positive sin squared x. Now let me divide the numerator by cos x and the denominator by cos x. So I'm not making any changes at all, because when you divide by a quantity, the numerator and denominator, you're actually multiplying by 1. So this is equal to 2 times sin x times cos x divided by cos x divided by cos squared x divided by cos x positive sin squared x divided by cos. Okay, now what I want to do is, I said I'm going to divide by cosech, right? But apparently I see that the impact is not what I wanted. So I'm going to change this to 2. Let me divide the numerator by cosh squared x and the denominator by cosh squared x. So let there be a cosh squared x, okay? So a cosh x and a cosh squared x gets cancelled, giving me 2 times sin x over cosh x divided by cosh squared x gets cancelled, giving me 1 positive sin squared x over cosh squared x. That's going to be tan, hyperbolic tan squared x. This can be rewritten as 2 times hyperbolic tan x divided by 1 positive hyperbolic tan squared x. And what is this? This is the all important formula of hyperbolic tan 2x. Okay, so this is a lovely deduction that I have produced here. So let us continue. We have 14 formulae. I will give still further. Now this is the next set of formulae. Sine of x positive y is equal to sine x cos y positive cos x sine y. Now this is for trigonometric functions. Now if you are to obtain it for the hyperbolic sin, it's going to be sin of x positive y, which is equal to sin x cos y positive cos x sin y. So there aren't any difference in the way the formula is written, except for in the presence of circular trigonometric functions we got the hyperbolic sin and cosh. Now the all important question is, how am I to prove it? If someone is asking you, how do you know, right? How do you know that the left side is equal to right side? So I'm going to show you that particular proof. Now we know that sin x is equal to e raised to the power of x negative e raised to the power of negative x divided by 2. So therefore sin of x positive y is equal to e raised to the power of x positive y negative e raised to the power of negative x positive y divided by 2, right? Now let me consider the right hand side. What's in the right hand side? Right hand side has got sin x cos y positive cos x sin y. Now we know that sin x is, let me write that, we know that sin x is equal to e raised to the power of x negative e raised to the power of negative x divided by 2, and cos x is equal to e raised to the power of x positive e raised to the power of negative x divided by 2. Hence my sin x cos y positive cos x sin y can be rewritten. In place of sin x, I'm going to substitute e raised to the power of x negative e raised to the power of negative x over 2. In place of cos y, e raised to the power of y positive e raised to the power of negative y divided by 2, and you have positive e raised to the power of x positive e raised to the power of negative x divided by 2 multiplied with e raised to the power of y negative e raised to the power of negative y over 2. Now let me, it's all product sign here, let me rewrite this by distributing. So 2 and 2, that will be 1 over 2 squared, and then you have e raised to the power of x times e raised to the power of y, e raised to the power of x times e raised to the power of y, then you multiply this, you got plus e raised to the power of x times e raised to the power of negative y, then you multiply this negative e raised to the power of negative x times e raised to the power of y, and then you multiply this, plus into minus is minus e raised to the power of negative x multiplied with e raised to the power of negative y. Now I'm going to handle this first, okay, and then I will come back to this, right? But anyway, I will just distribute this also. So it's going to be 1 over 2 squared, so e raised to the power of x times e raised to the power of y, and then negative e raised to the power of x times e raised to the power of negative y, positive e raised to the power of negative x e raised to the power of y, positive, negative, negative e raised to the power of negative x multiplied with e raised to the power of negative y. So this is what you have got. So what I will do now, I will rewrite, or I will simplify 1 over 2 squared. So if you have something like this, say a raised to the power of m times a raised to the power of n, I can rewrite this as a raised to the power of m positive n. So by that, this can be written as e raised to the power of x positive y. This is e raised to the power of x negative y. This is negative e raised to the power of negative x positive y. And this is e raised to the power of negative x negative y. So it's going to be e raised to the power of negative of x positive y. I've taken 1 over 2 squared out, so I can just write everything down. So it's e raised to the power of x positive y. I've placed, I need to get a negative there. Negative e raised to the power of x negative y. Positive e raised to the power of x positive y, and negative e raised to the power of negative of x positive y. Okay. Now these two can be added. Now positive e raised to the power of x negative y, negative e raised to the power of x negative y, that can be cancelled. Over here, this can be cancelled. So what is left? These two can be added also. So you have 1 over 2 squared of 2 times e raised to the power of x positive y, negative e raised to the power of negative of x positive y. With a 2 there, 2 can be taken out. So 2 over 2 squared times e raised to the power of x positive y, negative e raised to the power of negative of x positive y. A 2 and a 2 can be cancelled. So you got e raised to the power of x positive y, negative e raised to the power of negative of x positive y divided by 2. Now what is this? What is this? You see here, this is exactly what we've got. E raised to the power of x positive y, negative e raised to the power of negative of x positive y. That is nothing but Sinh of x positive y. Hence proved. Now this is one particular instance of the formula, right? And you can follow the same pattern. Let me write that down here. You can follow the same pattern for Cosh. So formula number 2, Cosh of x positive y will be equal to Cosh x, Cosh y positive Sinh x, Sinh y. No change. In circle function, the sign would get reverted. And now tan, hyperbolic tan of x positive y, formula number 3. This is equal to hyperbolic tan x plus hyperbolic tan y over 1 positive hyperbolic tan x multiplied with hyperbolic tan y. So it's positive all through. Now you might be asking me, what would be the situation if I have a negative sign? What would be the state for, let me write that down here, Sinh of x negative y. That is nothing but Sinh x Cosh y negative Cosh x Sinh y. Okay, so that is formula number 4. And you would also be asking me, what would be the situation if I were to have Cosh of x negative y? That is going to be Cosh x Cosh y negative. It's negative here, negative Sinh x Sinh y. Okay, so I have given you all these formulae and we move on. Now for tan, finally formula 6, hyperbolic tan of x negative y is equal to hyperbolic tan x negative hyperbolic tan y divided by 1 negative hyperbolic tan x times hyperbolic tan y. So negative comes here, negative comes here. Okay, so let us discuss the nature of functions. So that's the next topic. Nature of hyperbolic function. So when we talk about nature of hyperbolic functions, we are interested in knowing the function is even or odd. Now, given a function, you say f of x. Now, it is even if for every x, f of negative x is equal to f of x, and odd if for every x, f of negative x is equal to negative f of x. Okay? Now, having given you that, Sinh x is an odd function. That would mean if I were to substitute, let me write that down. Sinh x is odd function, right? So the meaning is Sinh of negative x is equal to negative Sinh x, and Cosh x is even function. So that means Cosh of negative x is equal to Cosh x. You get the function back. And hyperbolic tan x is odd along with hyperbolic cot x. Since tan of negative x is equal to negative tan x and cot of negative x is equal to negative cot x. Now, if you were to take secant x is even. Now, why do I say even? Because secant of negative x is equal to the original function secant x. Now, cosecant, hyperbolic cosecant, or you can say cosecant with its sound, is odd. Why do I say it's odd? Because cosecant of negative x is equal to negative cosecant x. Okay, I hope you got the essence of this particular lesson about nature of functions. So we move on. Next, we will see what is known as sum to product formulae. A very important concept in hyperbolic functions. That means if you were to be encountering Sinh x positive Sinh y, then this sum can be written as a product. 2 times Sinh of x positive y over 2 multiplied with Cosh of x negative y divided by 2. Okay, so this is the first one. The second one is Sinh x negative Sinh y. This is equal to 2 times Cosh of x positive y over 2 multiplied with Sinh of x negative y divided by 2. The third one we have for Cosh. Cosh x positive Cosh y is equal to 2 times Cosh of x positive y divided by 2 multiplied with Cosh of x negative y divided by 2. Right, I hope you are able to watch this. Next comes Cosh. Cosh of x negative Cosh y is equal to 2 times Sinh of x positive y over 2 multiplied with Sinh of x negative y over 2. Okay, so this completes the sum to product for Sinh and Cosh. Now I'm going to give you sum to product for tan and cotan. In other words, hyperbolic tan and hyperbolic cot. Okay, so that will also come in handy. Now these two functions, hyperbolic tan and hyperbolic cot, they are used for advanced challenges, in other words advanced complexities, to solve them. So let me write that down. 5 hyperbolic tan x positive hyperbolic tan y is equal to sin of x positive y over cosh x multiplied with cosh y. 6 hyperbolic tan x negative hyperbolic tan y is equal to sin of x negative y over cosh x times cosh y. 7 hyperbolic cot x negative positive cot y is equal to sin of x positive y divided by sin x multiplied with sin y. And 8, you got what is called as the difference, right? So cot x negative, that's hyperbolic cot y, hyperbolic cot x negative hyperbolic cot y is equal to sin of x negative y over sin x times sin y. Okay, I hope you got that. So 8 formulae for sum to product. Now we will move on to do some basic questions. Now, having given you the sum to product, let me give you also the formulae connected with inverse hyperbolic functions. Now we can write sin inverse as follows, either like this, or you can simply say arc sin x. Okay, now this is equal to ln of x positive root of x squared positive 1. So that's a formula for sin x. Now next is cosh inverse of x. When I say formula, for it means I am mentioning the sin inverse of x. So that's a formula for sin inverse of x. Now cosh inverse of x is written as arc cosh x, which is equal to ln of x positive root of x squared negative 1. So you see the difference here, and this is applicable for all x greater than or equal to 1. So that's the requirement. So having given you sin inverse of x, cosh inverse of x, we will now see hyperbolic tan inverse of x or tan inverse of x, which is equal to, you can also write it like this, arc tan x, hyperbolic tan x, which is equal to 1 over 2 ln of 1 positive x divided by 1 negative x for all modulus of x, or in other words I can say for all x such that modulus of x is less than 1. So that's the requirement there, because we can't allow this, if we don't place in this condition, this is invalid. Okay, so the next is secant inverse of x. So you can write secant inverse of x like this, arc secant x, which is equal to ln of 1 positive root of 1 negative x squared divided by x, and this is only valid if x is strictly greater than 0 and x is less than or equal to 1. Okay, now next is cosecant inverse of x, which is also written as arc cosecant x, and that has a formula as ln of 1 over x positive square root of 1 over x squared positive 1. And the last one, that's going to be cot, hyperbolic cot inverse of x, or arc cot x, and that is equal to 1 over 2 times ln of x positive 1 over x negative 1. This is only valid for all x such that modulus of x is greater than 1. So that is the validity. Okay, so I have dealt hyperbolic function in all detail. This is just the first module. Now what we are going to do is we will have to do some questions. Okay, so I'm going to do some questions so that it will act as a reinforcement of the concepts that we have studied this far. Now let's do some exercises. Question number 1, prove cos squared x negative sin squared x is equal to 1. How are we going to prove that? So foremost, what I wish to do is I will say consider left hand side. Left hand side is cos squared x negative sin squared x, and that is equal to, now we know that cos x is equal to e raised to the power of x positive e raised to the power of negative x divided by 2, and sin x is e raised to the power of x negative e raised to the power of negative x divided by 2. You substitute these over here. This would give us e raised to the power of x positive e raised to the power of negative x raised to the power of 2 negative e raised to the power of x negative e raised to the power of negative x divided by 2 raised to the power of 2. Now you can rewrite this as 1 over 2 squared, because 1 over 2 squared is common, and this is going to be e raised to the power of x positive e raised to the power of negative x raised to the power of 2 negative e raised to the power of x negative e raised to the power of negative x raised to the power of 2. Now this is equal to 1 over 2 squared. Expand this. This will give you e raised to the power of x whole squared positive 2 times e raised to the power of x times e raised to the power of negative x positive e raised to the power of negative x whole squared negative of e raised to the power of x whole squared negative 2 times e raised to the power of x times e raised to the power of negative x positive e raised to the power of negative x whole squared. Now you have a negative sign here, right? There's a negative sign here. Now remove the negative sign. In other words, distribute the negative signs. So I'm not going to do anything. I'm just going to write this as e raised to the power of x whole squared positive. This is going to be 1, right? They get cancelled, giving me 2 times 1, and this is e raised to the power of negative x whole squared negative e raised to the power of x whole squared. This is going to give me 1. 2 times 1 is 2 with a negative sign and a negative sign. That's going to be positive, and this is going to be negative e raised to the power of negative x whole squared. Now this gets cancelled with this. This gets cancelled with this. You have 2 added with 2. That's going to be 4. You already have 1 over 2 squared. That is 4. 4 and 4 gets cancelled, giving you 1, which is equal to right hand side. So this is a beautiful question. Okay, we got the second question. Use secant x expression in terms of cos x and also for tan x, and show that secant squared x positive tan squared x is equal to 1. Now what they are trying to tell us is, we got an equivalent expression for secant x in terms of cos x and also an equivalent expression for tan x in terms of cos x. We got to use them. Now they had only just mentioned the cos x, right? So that it means they are not interested in having tan x and secant x present in their original form. That's the understanding. So it does not mean that you cannot use any other identity or some other identity where another component of hyperbolic function gets involved. So having mentioned that, let me just consider the left hand side. Secant squared x positive tan squared x. Now we know that, what do we know? We know that secant x is equal to 1 over cos x, and tan x, hyperbolic tan x, is equal to sin x over cos x. So using this, I can rewrite this as 1 over cos squared x positive sin squared x over cos squared x. Now this is equal to, take cos squared x as the LCM, this will be 1 positive sin squared x. Now we know that, what do we know? Cos squared x negative sin squared x is equal to 1. So that means cos squared x is equal to 1 positive sin squared x. So because of this, I can rewrite this as, in place of 1 positive sin squared x, it's going to be cos squared x. Already there is a cos squared x in the denominator. Cos squared x gets cancelled, giving you 1, which is equal to the right hand side, hence proved. Okay, so that is the end of this question. This is the next question. Use double angle formula for cos 2x and write or represent the exponential equivalent. So what they're asking us is we need to represent cos 2x in exponential form. So for that we have to use the double angle formula. So what is the double angle formula? We know that cos 2x is equal to cos squared x positive sin squared x. So this is the double angle formula for cos 2x. Now we also know that, what is that we know? We know that cos squared x negative sin squared x is equal to 1, and that would mean cos squared x negative 1 is equal to sin squared x. This is one representation. The other representation is, we can always write cos squared x to be equal to 1 positive sin squared x. Now what I wish to do is, I would like to utilize this. So substitute in place of cos squared x this. Now before we could do that, we have to say, consider the left hand side. What is the left hand side? Left hand side is cos squared x positive sin squared x. In place of cos squared x, I write 1 positive sin squared x positive sin squared x. I add these two together, I get 1 positive 2 times sin squared x. Now we know that sin x is e raised to the power of x, negative e raised to the power of negative x divided by 2. Substitute that, it's going to be 1 positive 2 times e raised to the power of x, negative e raised to the power of negative x over 2 raised to the power of 2. This is equal to 1 positive 2 times of e raised to the power of x, negative e raised to the power of negative x raised to the power of 2 divided by 2 squared. So 2 and 2 gets cancelled, giving me 1 positive, take the square, e raised to the power of x whole squared negative 2 times e raised to the power of x times e raised to the power of negative x positive e raised to the power of negative x whole squared. You have a 2 here, so I'm going to place the 2 in that fashion. So this is equal to 1 positive. Now by exponent rule, e raised to the power of x raised to the power of 2 is e raised to the power of 2x. This is going to give me 1, and 2 times 1 is going to give me 2. We have a negative sign there, and this is going to be giving me e raised to the power of negative 2x. Now distribute 1 over 2, you get 1 positive 1 over 2 times e raised to the power of 2x, negative 1 positive 1 over 2 times e raised to the power of negative 2x. Negative 1 positive 1 gets cancelled, giving me e raised to the power of 2x. 1 over 2 is there, I'm going to take it as a common quantity out, followed by positive e raised to the power of negative 2x. Now this can be further rewritten as e raised to the power of 2x positive e raised to the power of negative 2x divided by 2. Now what is this? This is nothing but cos 2x, which is equal to the left hand side, hence proved. So this is exactly what we don't have to write hence proved. We just have to just say equal to left hand side, because all they want is to give us this, give them this representation. So once we give them this representation, the solution is complete. So we move on to the next question. Okay, so this is the next worked out example. This is called as the hyperbolic angle addition. Use hyperbolic sum formula to prove that tan hyperbolic tan of x positive y is equal to tan x positive tan y over 1 positive tan x times tan y. So foremost, what I wish to do is I would like to consider left hand side. What's in the left hand side? Hyperbolic tan of x positive y. Now this can be rewritten as sin of x positive y over cosh of x positive y. Now this can be further rewritten by the addition formula we know as shin x cosh y positive cosh x shin y divided by cosh x cosh y positive shin x shin y. Now I would divide the numerator and the denominator by cosh x cosh y. So that would give us shin x cosh y divided by cosh x cosh y positive cosh x shin y over cosh x cosh y divided by cosh x cosh y over cosh x cosh y shin x shin y over cosh x cosh y. Now cosh y cos x cos x cos x cos x cos x cos y cos y, and we can't do anything. We will have to write this in this fashion. Okay, so this will give you shin x over cosh x plus shin y over cosh y divided by 1 positive shin x over cosh x shin y over cosh y. Shin x over cosh x is hyperbolic tan x, shin y over cosh y, hyperbolic tan y. This is hyperbolic tan x. Shin x over cosh x is hyperbolic tan x. Shin y over cosh y is hyperbolic tan y. Shin x over cosh x is tan x. Shin y over cosh y is hyperbolic tan y. So this is what is required, right? We are asked to show this. So this is equal to right hand side. Now you can state hence proved. Now I want to give a list of questions for you all to work out. Please give the solutions in the comment section. Now if you have any questions, if you are unable to actually solve any of the questions, you please mention it in the comment box, okay, and I will show to you how to do the questions. Now having mentioned this, let me give you homework. Okay, question number 1, compute shin of 0 and cosh of 0. Now you have to compute this, right? And you can use the formulae that I have already given. Question number 2 is prove hyperbolic tan x is equal to shin x over cosh x. You have to prove this. That's question number 2. Now I have given 2 questions. These are 2 basics. So let me go up and give you the 3rd question. If shin x is equal to 1, find x. Next, question number 4, use definition of shin x and cosh x and express shin x multiplied with cosh x. Okay, there's a product there. Okay, you have to express this. That's question number 4. Question number 5, verify whether 1 negative hyperbolic tan squared x is equal to secant squared x. You got to do that verification. And question number 6, express sin to x in terms of sin x and cosh x. Okay, so I have given you 6 questions. I have worked out 4 questions and I have given you 6 questions. So solve these questions. Thank you, students. Until we meet again.